The global economy continues to collapse as food prices spike.
The world population has now reached its 8th billion mark.
Food has now replaced oil in becoming the most prized commodity.
Movies are already preparing us for this imminent scenario. But is it only fiction? Will we always be able to feed an exponentially growing population? Today's agricultural landscape is increasingly vulnerable. Huge water consumption. It has reached its maximum production capacity. The only way I can feed all the mouths on the planet is to use pesticides and chemical fertilizers heavily. Most of us know that our cars will not go far on poor quality fuel. But most people do not hesitate to put harmful food in their mouths and then wonder why their bodies shut down. Could we survive without eating? Since eating is a vital need, is there a better system we can use to feed us? A system using 90% less water? A system that can only produce tasty, highly nutritious food and provide a guarantee of healthiness by being intolerant to harmful pesticides? A system that could be installed in cities where most of the food is consumed, eliminating the need for costly transportation and intermediate handling? A system in which consumers would purchase food where it is made, thereby guaranteeing healthy manufacturing? A system where communities could meet and have fun together? A system that could support schools to teach sustainability and how the natural world works? A system that is a fun activity for families? This system exists. It is called aquaponics, and it replicates the natural ecosystem in which plants grow on fish waste and fish feed on plants. When properly designed, this system delivers phenomenal results. But how do we make sure it is properly designed? How do we balance the number of fish and the size of the fish tank to feed all these plants efficiently? What is the best way to grow various vegetables? Ceres Calculator provides this optimum balance. Ceres is not an AI app. It has been built using actual production data recorded over many years in aquaponics labs and farms. Based on your production area, the Ceres Calculator provides you with the daily feeding requirement for fish, the number of fish required, and the volume of the fish tank required. You have two modules available. Module 1 is designed for plants that grow continuously in trays, such as cooking herbs. Module 2 is designed for plants grown in batches, such as lettuce. To maximize plant production in batches, the planting density varies as the plants grow. Ceres lets us select our unit system: metric, meters, grams, square meters, or imperial, feet, ounces, pounds, square feet. We have space to design a system for 12 trays, each 6 square feet. And we plan to produce an average of 35 ounces per tray. Ceres gives us our expected monthly production, the quantity of fish feed per day, the number of fish we will need, and the volume of the fish tank. Now, we are going to design our lettuce area. We select Module 2, which is designed for plants grown in batches. Let's do a calculation for cause. We will use the metric system this time. Our floating boards have 60 holes. We will allocate 12 boards to cause. We plan to harvest our cause lettuce at 60 grams after 14 days at 100% density and after 14 days at 50% density. Ceres tells us the expected number of boards and the number of plants required at each density. Then, Ceres tells us how many seedlings we will need to germinate weekly, the number of plants, total weight produced monthly, and the fish engine size. Let's do another calculation for green oak. We will allocate another 12 boards to green oak and harvest them at 150 grams after 10 days at 100% density, 12 days at 50% density, and 16 days at 25% density. Ceres tells us the expected number of boards and the number of plants required at each density, how many seedlings we will need to germinate weekly, the number of plants, and the total weight produced monthly, and the fish engine size. Your Ceres Calculator membership also gives you access to Ceres Botanical. Ceres Botanical provides valuable information on how to grow over 50 vegetables aquaponically. Just select a plant, and Ceres Botanical will display general information, expected yield, growth cycle, and harvesting process. Advantages of growing the plant aquaponically: the optimum spacing for maximum productivity, the temperature range in which the plant thrives, the important nutrient requirements and most common deficiencies, the optimum growing system, pollination and pruning if necessary, and the most common pest attacks and diseases. Ceres also provides information on each of the 6 critical nutrients plants need. We regularly add new plants as we test them. In the following sections, you get information on pest attacks and nutrient deficiencies. Ceres Botanical provides information on the most common fish used in aquaponics, including expected size at maturity, growth duration, water temperature range, and diet. Ceres Calculator does not provide productivity information. You need to evaluate the productivity of the vegetables you plan to produce, such as 35 ounces per tray per month. Nevertheless, we have tested productivity across various water temperatures and daily light durations over the last 10 years, and Ceres Production provides this information for over 50 plants. Stay tuned for our next video introducing Ceres Production. Visit AHAS-Services.com for more details.